Welcome back to Getting Started with Linux. I'm your host, Daniel Lowrie, and today we are going to take a look at finding files. Probably a very important thing for us to do. And who's going to help us out with that? This guy right here, Ross Brunson. Ross, welcome back.
Thank you.
Now, I kind of set us up for this episode, as I like to do.
Nicely.
Finding files. There seem to be quite a few files on our systems here. And I'm guessing any given system is going to have quite a few files on them.
Right.
How can I find out, A, how many files are on this system, and B, what if I wanted to find a specific either type of file or file in that myriad, that needle in the haystack? Like, if I wanted to find all the text files,
Right.
what would I go through to find those out?
Well, this is going to be using the find command, which is one of the few commands that's named very, very explicitly.
Aptly,
Yes,
yeah.
it's unambiguous in the extreme. You find files with find. So what we'll do is we'll look at the concept of find versus a command called locate. The find command crawls the system as you tell it to and finds things in real time. The locate command is database driven, and so would have to have its database updated using the update db command. We'll kind of leave locate and update db alone, but those are there. The find command is the one that explicitly goes out and finds stuff in real time for us. Now that means it can take a while on a very large system, or it could also mean that it exercises the system extensively, depending on how many files there are. So let's switch over to our operating system here. And you had said, how would I find the number of files that exist on my system?
Right.
Well, we can use this great thing called the word count, or WC command. Word count is something that we would normally get lots of output on the screen. Instead, we can pipe that over to word count and say, show me the number of lines that are actually returned.
Okay.
So let's do a quick find command. Now you're going to see some error that comes from running the find command as a regular user. And so it doesn't actually count those.
Okay.
So we're going to run the find command, and we're going to tell it where to start from, the root of the system. We're going to say, I want every file, and that's case insensitive. Every single file name of any kind whatsoever. And we oftentimes will make a mistake and do an asterisk dot asterisk, and this gets misinterpreted by the shell and the find command. So what we'll want to do is put quotes around that. So it's just a simple thing, but that says interpret this as every file on the entire system.
Okay.
So we'll run this. Now you see that takes a long time, and it came back. What I can do to find the number of those is pipe it to WC minus L, and it'll come back and tell me there's 101,964 files on my system.
That's a lot.
It is. It is. It's a lot to look through as well.
So if I wanted to find all those text files, that if I had to do that manually, it would take me forever. It would be a job within a job.
A lifetime.
Yeah.
Yeah. And having had to look through systems for files that I didn't know what they were called, I can tell you the find command is the way to go.
Okay.
Now, remember, we talked about the concept of having an extension. If you don't have an extension on your file, it's really hard to find that file by the extension.
Yeah.
Okay. So what we do is we make sure that we have extensions, and then we'll go out and we'll look for everything that ends in .txt. So for example, let's go back to our system here, and we'll clear our screen and run that same command. Run that same command, but let's go and simply do txt. Now, because this is minus iname, that's case insensitive, and that's going to mean that it goes out and finds every file name, whatever, that has a .txt on the end of it. And that is also case insensitive. So capital TXT, lowercase txt, capital T, lowercase x, capital T, every possible combination. Let's find out how many we have. It was 719 on the system.
We've definitely pared this down now. It's making our job a little more realistic at this point.
Yeah, we can conceive of 719 files, but not 100,000 files.
No.
Now, let's say, for example, we wanted to make a great thing called myhugetextfile.txt.
Okay.
So myhugetextfile.txt, we'd strip that stuff off the end here. Let's say we want to search all of our text file contents, and so we put them in one great big file.
Okay.
I can do that by simply taking and stripping all that off, doing a redirect. We'll see if this works. Doing a redirect and call it myhugetextfile.txt. So it's going to find every text file in the system, and theoretically, it's going to be taking the contents of those text files and putting it into this one. You think that's the way that's going to work?
I don't know. I'll be honest and just
I set that up.
Oh no.
Okay, so let's take a quick look here. I have my huge text file.txt. Let's cat my huge text file. And what is it?
It's just the directories.
Well, it's
Or
just
the
simply the
path.
output of the
Yeah.
full path of every one of the text files on the system.
Okay.
I got to do something else in order to get the contents out of there
Right.
and stream it into the
So
actual
we're going to add
file.
another command or another option, another argument.
We sure are. We're going to use a very useful little option here. So instead of saying the output redirect straight to the text file, which gives us the output as we would see it on screen, we want to go ahead and cat or enumerate or expose the contents of each one of these text files. Okay. So your mind, after a little bit of use of Linux, would say, well, I know what we can do. We'll use the exec option, and then cat, and then we'll do this funky thing here, and then backslash semicolon. Now, for those of you who think that I have just suddenly lost my mind and started to type gibberish.
I thought you just were leaning on the keyboard.
That's how I got that in the first place. And so what I've done is I've used this option called -exec. Every one of those full paths and file names that would normally come back from the find command, -exec says, hey, on each and every single one of these, I want you to run the following command. The following command is the cat command. It could be anything.
Yeah.
Absolutely any command whatsoever. And each one of those lines of output that we would normally see on the screen is going to get tucked in between those two curly brackets. Those curly brackets say, they represent each one of the lines of output. So theoretically what we're going to do here is we're going to run the cat command against the full path and file name of every single one of those text files, take all that, and put it into my huge text file. Do you remember how many lines were in my huge text file?
There were probably, I did not see. I can't see.
719.
It was all the paths, right?
Let's make sure we have the original one and this one. Took a little longer.
I noticed it took longer. Yeah.
Right. So what we do is we run WC -L and my huge. There we go. And it comes back and it tells me that instead of 720 in the original one, I've got 400,689 in the next
It's
one.
a little bigger.
A little bit. So it did what we thought it was
did what we
going
thought
to.
it did.
Took them all and blasted all that into there. So this is just a good example of the find command. The find command can do so much more.
Seems very powerful.
It does. And so a couple of other fun, there's a couple of places where you can go, especially the man page, to find out more about the find command. But I do want to make a pitch for a book that I really enjoyed and is on my reference shelf. I have a copy in my home office or my work office. It's called Unix Power Tools. And Tim O'Reilly of O'Reilly Publishing is one of the original authors of it. It's in like its third or fourth edition. And it was the one that I turned to initially to find files. And so one of the tricks that I found in there is I can do this fun thing. So if I'm in here, is you can use the find command to tell you, for example, files that have occurred since a particular date or time. So let's go ahead and create a file, touch, and we'll call it my new reference file. That my new reference file has some particulars to it. So if we look at the ls-l output of my new reference file, you'll see that it was created July 11th at 13:36 p.m. We can also run a great command called stat. So my new reference file will now have more information. Stat gives you all kinds of things, including the device that it's on, the inode, the I/O block. It's a regular empty file, all kinds of great stuff. You'll see also access, modify, and change permissions. Times. The access time is when someone last accessed the file, such as enumerated it, catted it. Now, you notice that these are all extremely similar, as in identical.
Yes.
That's because they're all set to exactly the same time because it was just created. Okay? So if you modify something, modifying says, I am modifying the permissions or the name or whatever, and change equals the content of the actual file. Now, so I wanted to do that because what we're going to do is we're going to run the find command here in just a moment. We're going to try to find a couple of files. So we'll touch my new file 1, and let's give myself my new file 2 and 3. Okay, so if I run a let's do an ls-l on my new file asterisk, you'll see that those are created at 1337, a full minute later. Doesn't matter, it's the difference in the times. And so what you can do is, if you have a reference file, that reference file might be the last backup that you did. I will oftentimes create a file that says system backed up on, and then, whatever the date and time is, and that's my reference. So I can run on my system a find command that will go and find all files that have been created since that previous reference or backup. So let's do that. We'll do a find minus newer. Oops, sorry. Got to give it the right. Let's do / so it doesn't search the entire system. Minus newer, and then my new reference file. At that point, it goes out, finds those 3 files. If I wanted to enumerate what the date and time of those files were, it's very simple. So I would then say my new reference file minus exec, and then ls minus l. Remember to put the 2 curly brackets because it's going to stuff the output into there. And then we cap it off with a \, which says ignore the next character, and the next character says keep going until you're done. As long as output is coming from the find command, it will continue to run the minus exec ls minus l on it. So if we hit enter, we then see that has found the files. Okay, and so there they are, my new file 1, 2, and 3. Somehow I got the rest of the output in there, but that's okay. The key thing here is we want to make sure that we're finding these things and that we know what to back up now. I could use the find command to find the files and then back them up using the exec tar command on it as well.
Oh, they love to make things just work in like a flow, like an orchestration.
Exactly, right? They do. And so what's really important about the find command is that there's a bunch of options to it, but just go out and search for examples. And I want to impress upon you that if you can find something on the system, you can do anything to it. Find allows you to find anything on your system, no matter what it is, and do anything to it. Now, I think that's kind of powerful.
Yeah, it does seem like it. And I know for a fact that find can be used actually in hacking techniques to elevate privileges depending on some of the file permissions and things that happen. Find is a big deal when it comes to your operating system. So you need to get a good idea of how this thing works and get it locked away in the old head there.
Mastery of the find command is a very lucrative thing.
Yes, it is.
It is.
Now, is there any other commands that we would want to look at that might actually find files for us on this system?
We could look at locate real quick, but what I told you before still is active. The locate command won't know about anything unless the update db command has been run since that time. So since we haven't run the locate command or update db, I'm imagining it's not going to find those new files.
So a lot less accuracy when it comes to locate.
So if we do locate my new file .1.txt, I notice I don't even have locate installed.
It's not even installed.
Right. See,
there,
so locate is one of those
less
ones.
Ubiquitous.
Yeah, it really is. It's one of those things where you, about the time that you need it, you have to retroactively go back in time in order to run it so that you can get it. It's like, so we really don't tend to use that.
So just lean on find.
Lean on find. One of the tips about find to make sure that it doesn't consume all your system resources is to put it to the top directory of where you think things are. So for example, if you're searching for something that's likely to be in the user's home directories, do /home as the top of it, not the root of the system itself. Much easier on resources.
Makes sense. Thanks so much, Ross, for explaining how we use find. Great command, great tool. Definitely understand how it works. Be familiar with it. You're going to love it. That being said, we are done with this episode, but we have plenty more in our series. So join us then. Until then, we'll see you next time.